Hey guys, I want to go ahead and talk about some of these graphing rational functions. I want to go ahead and do a kind of complex problem. So here we got this problem right here. The first thing I want to do here is I want to see if I can simplify it. So I'm looking at it, I look at the numerator, I think I can factor out an x from the top. So when I go ahead and do that, I'm left with x on the outside, and that is x squared plus 5x plus 4. On the numerator, I have this guy here. I'm going to factor out the negative along with the 3 on the denominator right here. That's going to leave me with x squared plus 4x, and that's a positive 3. And if you notice, now I have quadratics, and these can be factored still further. So if you factor the top, this guy here should give you what is that? X plus 4 times x plus 1. On the denominator, you have that negative 3 on the outside. That becomes x plus 3 times x plus 1. Okay? And I noticed right away that the x plus 1s can simplify out. I could do that. Okay, so what does that mean? Remember we learned when these guys cancel out, they cross out. That means there's a hole at x equals -1. So there's a hole at x equals -1. Alright, that helps me out a lot. The next thing that I want to go ahead and do, now that I have that, I have my new equation. So I'm going to go ahead and write it over here. So f of x is equal to x times x plus 4 divided by -3 times x plus 3. And that makes it a lot different. If you think about, if you have 4/8 and you want to simplify, that becomes 1/2. 1/2 is a lot easier to work with than, big numbers. So that's all we did. We just kind of made this fraction smaller. And since I really can't do much, I'm just going to go ahead and multiply it. Let's see here, x squared distribute plus 4x, just because I know I'm going to have to be doing some algebra and distributing and multiplying and whatnot. So this is my new function that I'm working with, okay? So I simplified it out. I noticed that I'm going to have a hole at x equals -1, and I'll go ahead and use that later. But the best thing to start with, guys, is you want to go ahead and figure out the y-intercept, okay? That's just want to get an anchor point, some point of reference. So to get the y-intercept, we want to set the x equal to 0. Okay, so we have f of x is equal to x squared plus 4x divided by -3x minus 9. And if you notice, remember, f of x, that's your y, these are your x. Okay, if I set x equal to 0, this is 0, this is 0, we're going to get 0 plus 0. And then 0 divided by, what is that? 0 minus 9 is -9. Therefore, the answer is 0. So my y-intercept is 0, 0. And that's great. That's another point of reference. So let me go ahead and just kind of start doing this guy right here, sketching it. Okay. So I have my x-axis, I have my y-axis. I know we have a point of reference, 0, 0. Right there. Now, at x equals -1, I'm going to have a hole, but I don't know exactly where that's at, so I'm just going to kind of leave it for right now. Okay, and actually I can figure it out by plugging this guy into here, but I'm going to leave that for later. Okay, so I simplified it, I factored it out. Okay, simplified this guy, I crossed it out. I know I have a hole at x equals -1. Okay, I found my y-intercept. Okay, set x equal to 0, I got that. So let's go ahead and do the second thing. Let's go ahead and, now that I find the y-intercept, let's find the x-intercept. How do I do that? Well, we're going to set y equal to 0. So if this is my function, okay, this guy's going to be my 0. Okay, so we're going to have 0 is equal to x squared plus 4x divided by -3x minus 9. So now I have to solve that. And what you can do is you can make this guy into a fraction. And what a lot of students do, they just kind of cross multiply. You've done that in probably algebra 1. So negative 3x minus 9 times 0, well, that's going to give you 0, okay? And then 1 times this numerator over here, that's just going to give you x squared plus 4x. And now you just have to go ahead and solve this equation. And if you notice, you're going to go ahead and factor out an x. You're left with x plus 4. So, therefore, we're going to have x equals 0 and x plus 4 equal to 0. That means x is equal to negative 4. So, these are your x-intercepts. Okay, so when y equals 0, we have this guy here 0, comma 0. And then the other one is negative 4, comma 0. Okay, so we found the y-intercept, now we found the x-intercept. And you notice we already have 0, 0. So the next one is negative 4. So let's see, 1, 2, 3, 4, right there. And that's good because it's going to help me, as a point of reference, graph this guy. All right, so I simplified it. I got my y-intercept. I got my x-intercept. Now I know we're going to need asymptotes. How do I know we need asymptotes? Because this guy is a fraction. Okay, so let's go ahead and do the first guy I want to do is my vertical asymptote. How do I find my vertical asymptote? We've done before. All I have to do is look at the denominator. Okay, now you can use this guy over here, but that's going to be a lot more work. Remember, I simplified everything, and now I have this guy right here. These two are exactly the same, but I want to use this guy because it's a lot easier. So my vertical asymptote is just taking this bottom denominator, okay? That's going to give me my domain, remember? Okay, so we can say domain. Remember, we can't divide by 0. So therefore, if that's the case, negative 3x minus 9 cannot equal to 0. Bring the negative 9 over, negative 3x cannot equal to positive 9. And when we divide, we're going to get x cannot be equal to negative 3. So that automatically tells me that's my vertical asymptote. So negative 3, 1, 2, 3 is right over here. So we're going to do this guy right here. And you can keep going further. Good, so that helps me out some more. So I have my vertical asymptote. Okay, now I need my horizontal asymptote. It's going to give me a frame of reference. So in order to do my horizontal asymptote, I have to look at the function. So I have to look at this guy right here. And you have to look at the leading coefficient right here. And if you notice, you have x squared and you have negative 3x. Okay, now if you notice, they're not the same. This guy is smaller, so the x can fit into the x squared. What does that mean? Well, that means we have no horizontal asymptote. Well, what do we have? Well, we're going to have a slant asymptote. Okay? We're going to have a slanted asymptote. Well, how do you figure that out? Well, you're going to have to use long division. Okay? We're going to have to use long division to do that. So here's what I'm going to do. I'm going to go ahead and divide this guy. So we're going to have negative 3x minus 9, long division x squared plus 4x. And I'm just going to add a 0 just because I need a constant. So we're going to go ahead and do long division. Now remember, in order to do long division, you want to make sure you match this guy up. So we have negative 3x and x squared. So what do I need? I have an x. What do I need to get x squared? Well, I need another x. Okay. But the problem is negative 3 times this is going to give me negative 3. That's not going to help me out. I needed to cancel out. I needed to match this exact thing. So I need to figure out what do I need to multiply to make it a 1. And what you're going to need is you're going to need a 1/3. And actually you're going to need a negative 1/3. Okay, so negative times negative, that's a positive. 3x times 1/3 x. Okay, that's going to give you your x squared. Okay, so 3 times 1/3, that's the 1. And you notice when we subtract, this guy's going to cancel out. This guy's going to simplify. So that's what I want. And so then we continue. Negative times negative, that's a positive. And then 9 times 1/3, well, that's just going to give you 3x. And that's nice. That's what I want. So these guys cancel out. 4 minus 3, that becomes 1. And then you bring down the next guy, x plus 0. Okay. So now I have negative 3x and then x. So how do I make this guy to become an x? So same problem here. So negative 3 times what gives you the 1? Well, negative times negative, I have to match it up. This is a positive, so negative times negative is a positive. 3 times what? Well, 3 times 1/3 is going to give me a 1. 3x times 1/3 is going to give you a positive 1. And then negative times negative, positive. 9 times 1/3, that's going to give you a 3. And that's a minus, and then you're going to 0 minus 3 is negative 3. And this guy, you remember, is our remainder. Okay? But for us, because we have a slant asymptote, this is my equation of the slanted asymptote. Okay? So this is what I'm going to graph. This is going to be my dotted broken line. I don't care about the remainder. That's not useful. So negative 1/3 x minus 1/3. Okay? So that's the equation of the slanted asymptote. Okay? So let's go back over here. Let's see here. Let's say that's 1, that's 2, that's 3. Okay, negative 1/3 is probably somewhere here. And then I have to, the slope is negative 1/3. So see, negative 1, let's see, 1, and then over 3. 1, 2, 3. So maybe somewhere here. So how do I do that? Well, 1/3, negative 1/3 is right here. And then I just kind of count at the same section. So 1, okay, 1, and then 3 to the right. So negative 1 down, 1 unit down, and then 1, 2, 3. And then this guy looks like it's right here. This guy right here. I'll use that. And this guy becomes something like this. There we go. So you see that it's going to be looking something like this. Now it's giving me more of an idea of what's going to look like. Now it's already kind of coming together, and you notice that this x-intercept, it looks like, because see, I don't know if the graph is going to come here and here in the middle, or is it going to come outside. And notice a lot of times with these, they're always going to be reflecting opposite of each other. Okay. Now I noticed that I have an x-intercept here, so this guy, when I sketch it, I think it's going to do something like this, and it's going to hug the asymptote, like so. Okay. Well, what about this guy over here? Well, it looks like if it passes through the origin, it's going to go right here.